Most business decisions are made on the basis of sampling result. In some situation, we have a population about which we have some information. However, most of the time, we don't have information on the population. Thus, we need to make decision based on a sample. From our previous video, we have shown how a sample mean can represent the population, where we take sample repeatedly from a given population. The average value of the sample means will equal the population mean from the underlying population. Now I will show you here how we use the sample and its sampling distribution to make a decision. Let us consider the following case. A small hair salon in Denver, Colorado averages about 30 customers on weekdays with a standard deviation of 6. It is assumed that the underlying distribution is normal. In an attempt to increase the number of weekdays customer, the manager offers a $2 discount on 5 consecutive weekdays. She reports that her strategy has worked since the sample mean of customers during this 5 weekdays period jumps to 35. Based on the underlying information, we would like to know how unusual would it be to get a sample average of 35 or more customers if the manager had not offered the discount. Do you feel confident that the manager discount strategy has worked? So, there are 30 customers in average on weekdays with a standard deviation of 6. We would like to know from 5 consecutive weekdays how likely it is for the salon to have 35 customers. Or, in other words, we would like to know the probability that the salon will get at least 35 customers. To find out, our first step is to convert the number of customers into the standard normal value or the Z value. From the formula here, we can count the Z based on the known information. And we get 1.86. Now we would like to know what is the probability that the customer is at least 35. Since our Z table shows probability value for area of the left of the Z value, thus we need to subtract the probability we obtain from the Z table. So we need to find out the probability of 1.86, and we are looking for the probability that Z is greater than 1.86, or this shaded area here. So from the table we get that the probability that Z is less than 1.86 is 0.9685. In conclusion, the probability that Z is greater than 1.86, or the shaded area here, is 0.0314. In other words, the probability that X is greater than 35 is just 1 minus 0.9685, or around 3%. Without the discount, we can conclude that it is fairly unlikely to reach the number of customers to 35. The probability is only 3%. So, can we say that the manager discount strategy has worked? Yes, we can, because by giving the discount of $2, the manager can increase the numbers of customers to become 35. So this is an example of the use of sample distribution of sample mean. We didn't take the sample repeatedly, but by taking one sample, using the central limit theorem and the characteristic of normal probability distribution, we can use it to make a decision in our business.